Hey, and welcome to this DBWatch webinar, where we look into boosting your database performance with DBWatch. Today we have two presenters. Can you please introduce yourself, Mark?
Hello to everyone. My name is Marek Jablonski, and I have been working with DBWatch for over 20 years, mostly as a DBA and developer, and some of that knowledge I am going to share with you today. Right?
Thank you, Mark. My name is Per Christopher Undheim. I'm the product manager for DBWatch Control Center. And today we will look at cross-platform monitoring when it comes to performance, where you can track performance across multiple database platforms, and how you can work across all those multiple platforms as if they were the same type. And how we collect data with our smart data collection, and how these snapshots can be configured without overloading your network or your storage. And also how we use the visual performance insights and interactive graphs to analyze SQL performance over time, and how this also scales and work across your multiple databases with our farm views. Some of our webinar attendees today are new to DBWatch Control Center, so I'll quickly introduce it. DBWatch Control Center is a powerful database management and monitoring solution designed to help businesses manage their databases effectively. It provides real-time monitoring, alerts, comprehensive reporting for a variety of database systems, ensuring your databases are secure, performant, and compliant. With DBWatch Control Center, you can automate maintenance tasks, schedule regular checks, gain deep insight into your database environments, all through an easy-to-use centralized dashboard. Whenever you're managing a single database or an entire enterprise-level system, DBWatch is here to simplify your database operations and reduce manual effort, giving you peace of mind that your data is always under control. If you're interested in a demonstration of the product or have technical questions, please reach out to us or from our support page, or book a meeting on our webpage at dbwatch.com. Can you please take it away, Mark, and please educate our community?
Yes, thank you, Mark. Thank you very much, Per. One of the key strengths of DBWatch Performance Module is its support for all 6 major database platforms: Oracle, Microsoft Server, Postgres, MySQL, MariaDB, and Sybase. And this cross-platform consistency means that DBAs and IT teams can work across different technologies using one unified tool with common interface and approach. And if you are an expert DBA on one platform and managing a mixed environment, this cross-platform consistency allows you to seamlessly switch between database types without needing deep knowledge on all platforms. So before I begin reviewing the performance module in DBWatch, it is important to ensure that the correct license is enabled, and I will show you later how to check that and how to enable it. You need at least the demo license, or if you bought our product, you need the SQL performance package enabled on the instance you want to monitor for performance. So the first step in using DBWatch Performance Module is to install the SQL statistics job on each database you want to monitor. And this job is responsible for collecting key performance metrics, which you, after that, can analyze. So how does it work? This SQL statistic job consists of a stored procedure and some set of tables. The procedure is executed every 5 minutes as default, and this procedure will then take snapshots of system tables where all the statistics regarding SQL statements are. And those statistics then will be saved into the local tables in DBWatch schema. So DBWatch does not transfer any performance data across the network, and all data stays on the instance which you monitor. Advantages are, of course, there's no network traffic, so you're not streaming any data into the central repository, and of course you don't have the repository, which can become huge if you monitor tens or maybe even hundreds of instances. But there are also some considerations because you keep all the data on the instance you are actually monitoring. Maybe you have some trouble with those decisions, so you have to keep eye on that instance and monitor also how much resources you are consuming by running this store procedure. So let's switch into DBWatch Monitor, and I will then show you how this job and how where we find this job. So I will just find a remote desktop where I have, here it is. So this is DBWatch Monitor, and on the left side you will see some icons. The top icon, first icon, is the monitoring part, and that's the view, the monitoring view. In the tree we have all groups defined on the system, and if I click on a group I will see all the instances defined in that group. For our purpose, I will switch grouping by type. So now I will have SQL instances here, and I will have MySQL, Oracle, and Postgres. That's my environment. And let's see if we open Microsoft SQL Server, and I have instance which is version 2017, and there's an instance there. When I click on it, I will see all the jobs installed on that instance. And the job we are interested in is the job name. Of course, I was supposed to click on this one. Here's the job name, SQL Statistics. The name of the job is the same name on every platform. It is only different versions, but that's the name. As you can see, the job is scheduled per default every 5 minutes. Of course, you can adjust that and collect that data more often or not that often. And parameters, which I will describe for you. So configure. So one of the parameters is the DBWatch database max size. Of course, the name of the parameters may differ between platforms. So we don't have a database in Oracle. Then we talk about table spaces. So it's a little bit different, but more or less the same. So this one shows you how big it can be this DBWatch repository. So 10 gigabyte default value for Microsoft SQL Server. If you reach 80% of that repository, then you will get a warning. You can, of course, configure it so you get an alarm or warning, or you can just ignore it. So if the job is running for some time and collecting a lot of statistics, and you reach 8 gigabyte, then the job will actually stop, and you will get a warning, and then you can make the repository bigger. You can make the max size, let's say, to 15 gigabyte, then the job will resize the data file and start collecting statistics. So that's one of the parameters. There's another parameter, history threshold. Per default, we are saving statistics for 1 week, for 7 days. Of course, you can adjust that, but be aware if you're saving data for many weeks, then the repository will get much bigger. Collect execution plans is one of our parameters with default value null. I put it yes because I want to save the execution plans. In SQL Server, execution plans take a lot of space. So the query could be very small and the execution plans could be large. So it's consuming much more space when you are collecting execution plans, which you would like to, of course, to have if you want to analyze some of the statements which you will capture by this procedure. So here you have the parameter. There's another parameter, check missing indexes, because this information about missing indexes is in execution plan. So this Microsoft SQL engine is checking all the columns in workflows, and if some of those columns are not indexes, then it will write that the index is missing. Even it's maybe you don't need it, but it will be marked as missing index. And even so, if the parameter don't collect, so you are not collecting execution plan, the execution plan will be collected for statements which where you have missing indexes automatically. There's another important parameter, mean logical reads. So this is the level of so minimum logical reads value per execution for a SQL for that this SQL statements job to be registered into the history table. So the reason for that is that if you have some statements which are not consuming any resources or very little, you don't actually have to save the information about that. So you just save statistics for statements which are consuming more resources, and then one of the resources are of course the logical reads, the amount of data read from data cache. So here you will see parameters. Actually, the table below shows you all the other instances where this job is installed. You can see that the version is different because they're different platforms. But let me just jump into Oracle, select a different instance. So here we have Oracle instance, and here we have SQL statistics job. Very similar, different version, same schedule. And also you can click and see the configuration. Here we call it minimum buffer gets, so not logical reads, but we call it in Oracle, you call it for buffer gets, but it's same metrics, but different names. And let's say if we take a look at Postgres instance, here we'll also have a job name SQL statistics, and you can configure it. And here the name is meaning logical reads to even call it buffer hits or something like that. So this is the job which must be installed on every instance to be able to collect statistics. Otherwise, we won't have any data to analyze. So that was the first step. You install it. You, of course, have to wait for some time so the SQL statistics job can collect some statistics, and then you are ready to switch into the management part. So the next most important step will be to analyze the collected data. Once the SQL statistics job has been run for some time, it will gather a significant amount of performance metrics. So yeah, and as mentioned earlier, we provide a unified and consistent view for analyzing performance data across all supported platforms. So it looks very similar when you work on Oracle or SQL Server or Postgres or MySQL. It will look very, very similar. So it's easy to switch even if you are not familiar with all database platform. So let's switch to live demo once again. So as you remember, this was the monitoring view, the first icon on the left. The second icon is the is for management, so you can interact with those databases, and you will see soon the performance module. So I will also switch into the per type, and I will start with Microsoft SQL Server. We'll find the instance. So here's the instance, just a short overview. And in the tree here, below the name of the instance, you will see the SQL performance view. And if you don't have the job, if the job SQL statistics is not installed, this view won't appear in the tree. So we select here and we see our view in a second, like this. So at the top, you will find an interactive graph that allows you to zoom into on specific time intervals where activity or anomalies may have occurred. So you click on the graph and you hold it, and you can, let's say, drag to the right or left, and you can specify a time interval. And we look at the logical reads which will reflect activity on the instance, and those logical reads are performed by all SQL statements recorded in the selected period. So of course we see the logical reads, logical writes, and physical reads. In normal system, you will have, of course, very high values for logical reads and not that high values for the other two. So let me go reset. Per default, we see the last 24 hours, but you can see for last 8 hours or 2 days or last week, and that's the default time frame we use to store the data. You remember the parameter name, history, threshold, or something like that. So you can, of course, look at all statistics, but usually you know the time frame you want to look at. So maybe it's yesterday, or maybe it's a few days ago. You can go to that time interval. So let's say 2 days back, and reset. So now we see a statistic from 2 days back, and then you can see, okay, I would like to see this part of this time interval like this. As I told you, we look at the logical reads collected by all statements during that period, and those statements which are using most logical reads are shown in the table below. Of course, you can choose to view those with highest values of logical writes or physical reads or execution or elapsed time. It depends on what kind of statistics are collected during for that platform. It's a bit different from platform to platform, but they are very similar. And I will show you later how to drill down into that table. So the table, so you have one record for every statement executed during that time frame. And at the bottom, there are some supplementary charts that provide additional context and help validate patterns or supporting findings for the main table. So there are some other jobs in DBWatch which are collecting different statistics. So let's say there's a job weight statistics which also runs every 5 minutes and collects statistics for weights. And of course, you can look at those statistics and see is there any correlation between this event and that event, and see if, yeah, just for investigation. Same, let's say, sessions. There's another job which is collecting statistics for how many sessions are connected to the instance, how many of those sessions are active, and so on. And maybe this is relevant. So that's the supplementary graphs, and types of graph depends on the platform and what kind of jobs are installed there, and so on. So here's another job collecting information about CPU usage for Microsoft SQL Server. So let's go back to the top graph here. I will reset the statistics once again. You have also another graph here. You remember where I was explaining those different parameters for SQL statistics job, and there's a parameter named minimum logical reads. So when we analyze all those statements in memory, if a statement has perform less than 100 logical reads, then we just skip it and don't save it into repository because you probably are not interested in it. And of course, there will be most of them will be very little demanding resource demanding queries, so they are not saved into repository. So you would like to know how much of logical reads are actually not monitored at all. And so you see here in our case, let me see if I can zoom into that. So you see it's around 10% of logical reads from statements which are not registered. Were not monitoring them at all. So it's okay. So if you increase this filter, you will lose more and more. If you increase the value of this parameter, you will lose more and more statistics. If you make it smaller, then you will collect more statistics, and also the repository will be bigger. So just be aware of that. So let me reset once again and select the time frame. So let me see, we can take a look at this time period. And now in the table, we see all the statements, SQL statements, which were run during that period. You can see, so there is one record for each statement. A statement could be as complex as stock procedure, or it could be single select, or maybe an update or delete statement. So you have one record for that, and you will have some cumulated values for logical reads during that period, logical writes, and all the those different statistics and metrics. And as I told you, you can sort them by different metrics, and you can display 10, 30 or 300 records at a time. So let's take a look at the one on the top, which is consuming most of logical reads during that period. So you just right click and show statistics, and then you will see the statement here on the left, which is in our case quite complex. It's actually a stored procedure which contains a lot of DML statements and selects, of course, and together all those statements run inside this procedure would generate this amount of logical reads and logical writes and physical reads. So you see how much resources this procedure has been consuming, and if you compare with total values, it's half of it, more or less 200 here, and here's 100. So this procedure alone is consuming half of the resources during the normal execution, not here, but here and here. The procedure, so it's not the procedure, but that's the statements inside the procedure which are consuming those resources, logical reads, writes, and physical reads. And so you can, of course, look at the procedure. Here's the first select inside this procedure. And in the table on the right, you will see, so this will be the first statement in the procedure. So you can see that, and you can see that the second statement will be here. So it shows statement. You can see this is the second statement, and the last statement in procedure would be something else, probably this one. So let's take a look. Last statement in procedure here. So you can see all those statements inside the procedure, and you can then take a look at the procedure and see, okay, how much resources, logical reads, logical writes, and physical reads is this statement alone consuming. So you select, just right click and select show SQL statement and statistics like this. And now you can see, okay, this one, you can see the statement, and you can see how much logical reads and logical writes these statements consume. And of course, you see this very little. So it's a fraction of the total amount of logical reads consumed by the whole procedure. So of course you can take a look at some of the statements here which are consuming much more resources. So this one here, so let's take a look at this one. So this one is much more, 50,000, and some spikes up to 30,000 logical reads, and probably more here. So take a look at, let's take a look at this one, show like this, and in here is more or less the same. So you will see those different statements inside the procedure, and you can see what statements are responsible for for logical reads performed by that statement. So let's just take a look at another statement. Here's a statement just executed once during this time period. At that time, 1545. Okay, let's take a look at what we have here. Show statistics. Then you can see there's just one statement. Select. Yeah, there's some kind of select. So that's why you have just one record here. And you can you can also click here, but then you will get exactly the same value. And as you can see, you have some options to see query plan and query plan using Management Studio. I will show you it in a minute. So here is another one. So there's also a quite nice column here named missing indexes, because during in the execution plan, the SQL Server engine will write information about columns which are not included in workflows. So then you can investigate that too. So let me see. So in our time frame, we don't have any SQL statements where we have missing indexes. So let me reset this one. And I remember we did have something yesterday. So let's take a look. Yes, here we have statements. So let's take a look at this one. Show statistics. So here we have also another procedure. This is DBWatch, of course, procedure responsible for collecting, read and write statistics from data files. And this procedure includes a lot of different statements inside, which are responsible for all the resources consumed. The values are very low, so don't have to worry. So let's say here we have missing index for that statement. So let's take a look at that. Show statement and statistics. So now we see there is a insert. It's a subquery inside the insert, because insert doesn't consume any resources, but we have a select. So the select is actually consuming those resources, and you can see spikes here and here. Okay, so we can try to investigate it a little bit more. So now we click and we can. So this one will be enabled if you have some missing indexes. So you click here, and we just read from the XML. So the execution plan is in XML format, and here we get the information about the object, the table, and the column which are missing an index. And of course, you can look at the query plan. It's in XML format, so it's not so easy to read. So instead of reading the XML file, you can use the Management Studio, the Microsoft Management Studio. It's of course, to be able to use this feature, you have to install Management Studio on the same computer where you run DBWatch Monitor, and configure it correctly so it can start as MS file. So it will start it for you, and then you can see at the execution plan for that statement. Yeah, I can put it down. So that's basically how you look at the statistics. There's another case where sometimes you know the name of the table you want to and you want to find some statement which extract data from a specific table. Let's say you create an index on a table, and you want to see, okay, how are statements, how much resources the statements are using now against this table. And because it's not easy to find them, because they shouldn't be on the top, maybe everything is well tuned, and you want to see how those queries are performing against this table. So instead of switch looking at all rows, it will be difficult to find. So what you can do, you can use this menu find text and specify the table, let's say. So I will type quite central table in debug schema checks like this one. You can run it, and then you will get similar table like this one, but now all these SQL statements inside that table will have this text inside, and you will see the statistics. And from here you can then analyze the statement and see, okay, what's going on. So here, of course, we have also, so this one will appear for this. So here we have DBV checks history table, so not DBV checks, but you will find this statement, and then you can see how the statement is performed. Here is once again a stored procedure. DBWatch consists of a lot of stored procedures. Every job that we run on the instance is a stored procedure, so that's why we have there's a lot of stored procedures in memory. Yes, so that's the way it looks, as you can see. If we switch to a different platform, so let's say if we look at Oracle, and there's version 12, okay. You will also see SQL performance here, and here we, instead of logical reads, we have buffer gets, which are the same metrics, but the name is different. You can select your time frame, and once again you can click on the top statement, show statistics, and you will see, okay, here we have a spike, and this is the gather database stats. That's the Oracle jobs which gather statistics for you, which is very resource demanding. Of course, you cannot show the query plan for procedure. You have to be, because that's the procedure doesn't have a query plan, but the statements inside the procedure. So let's take a look at another one. Show statistics like this. So here is actually a statement, and you can click here and show query plan like this, and it's a different format. Extract this information from Oracle. So for Oracle DBAs, this will be normal stuff to look at. Maybe not so user friendly, but it gives you some kind of information. But the most important part is that it looks very similar to what we have seen on SQL Server. We have also some supplementary charts on the bottom, and once again it will be depending on the platform. So we'll also have weight statistics. So there's a job which collects weight statistics. There's also another job which collects session statistics, and other things. So also depends what is installed. So let me take a look at another platform like Postgres. So here we have this, and once again here we have this SQL performance, same name, and once again same, more or less same view. Logical reads, this time in Postgres you call it block hits. Same metrics, the same different names. Again, table in the middle where you can see the statistics for that statement, and you have some supplementary charts in the bottom, same like for the others, the number of sessions, for example. So this is how the performance module looks like. As you could see, it's very similar on all platforms. But the third and final step is to monitor the internal repository, because if you have if this SQL statement job has been running for some time, you will have to take a look at the statistics, and it is important to keep eye on storage and usage and growth over time. So let's switch again to debug monitor, no desktop, it's here. So let's go back to Microsoft SQL Server. Here is the main view where you analyze your data, and just below SQL performance view, you have internal repository. And we aim to be fully transparent about what data is collected and how it is affected, how it affects your system. So the overhead introduced by the SQL statistic job is minimal, hopefully, which ensures that the performance data can be collected without impacting the system's workload. But anyhow, you have to take a look and to be sure that everything is okay. So those two tables, two graphs on the top, they show you how much space being consumed by those different tables in debug schema, debug database over time. And you see the size of the database. For Oracle, that will be table space, different things on those different platforms. You see size of those individual tables and cluster index or indexes. The quite important view graph is here on the right, which shows you execution time of the procedure. So every time we run the procedure, we calculate how long time it spends during execution. And remember, we are executing this procedure every 5 minutes. So you don't want to run it for 5 minutes because then you are using too much resources. As you can see here, this procedure runs for around 2-3 seconds, which is 1% of time. The time is spent between executions. And you can see actually the table below shows you some statistics for every execution of the procedure. So we see that in memory we have 4,728 handles. It's SQL statement, but remember, a handle could be a stored procedure, which contains maybe tens of SQL statements like selects, updates, and deletes. So on normal production instance, you will have much more, maybe 20,000, 50,000. It could be also 100,000. So it will take longer time to analyze all this data. But of course, the server is much faster and CPU is probably doing calculation much faster than on our test environment. The other columns, next column shows new handles, which have never been seen before. That's 6 here. And the active handles, which have been registered before, but now we have a new snapshot of and new statistics for those handles, and some inactive. Here we can see the number of handles which are not active, the limit as a SQL. So you can see that more than half of the handles are not registered into history tables. And you have some other. Here you can see the number of buffers for all the statements which are not collected, so the value is not that high. And there are some other values, how many records you have in those different history tables. And important values here, the execution time. So you see it takes around 1 second, 2 seconds to execute this stored procedure. So here you will have excellent overview of the repository, which is local on the instance you are monitoring. And I would say that this graph is the most important one because there's no problem with space. But if the procedure is using too much time to execute, then you have to adjust parameters, and so the procedure is not spending too much time. So let's take a look at the other platforms. So here we have Oracle. So once again, this is performance overview, and here we have the internal repository. And once again, it looks almost identical. We see those segments and how much space they are used. Instead of database, there's a table space. And here is the graph showing us how much time the procedure is spending using during execution. So here is less than 1 second. It's between half and 1 second, so it's executing quite fast. There are not so many statements in the memory, just around 2000 SQL statements in the memory. And of course, in a normal production site, you will have 10,000s of statements compiled and ready for execution. So it will take more time to analyze it. And if we take a look at the Postgres, it will be more or less the same. Here we have even less statements in memory, and the procedure is executing in a fraction of the second, but there's actually nothing there. So that's why. So those views are okay, but if in a larger environment where the performance module is deployed across dozens or even hundreds of instances, it becomes essential to maintain centralized control and visibility. Otherwise, you won't be able to find anything. And this is where the farm views module in dbwatch comes in. So let's switch to dbwatch monitor once again. Okay, so the first icon on the left is for monitoring, where we could see all the jobs, the SQL statement jobs, you remember. And then we were analyzing data collected by performance module in the management. And of course, you can look at individual repositories. But then if you have many repositories, then it will be not so practical to go from one to another. You will lose the overview. So what we have is the farm views. Well, it's a different way of looking at your environment, and you can see in our test environment we have 36 instances. Altogether we have 277 databases, and we see the additions we are using, what versions, and this kind of information. But what we are interested in is the SQL statistics view. And here we can see at once that there are 20 instances where this job is installed. And we can see the repository size and some metrics regarding the execution time, the average execution time, maximum average execution time, last execution time, and so on, and some information from every job. And of course, dbwatch you can be connected to different locations, and so you can have distributed information from different sites. So here we have just one dbwatch server, and we also split the information between platforms because there are some small differences which are not easy to show in a single view. So if we click on SQL servers, then we will see all the repositories on SQL servers. So we have 6 of them. So again, we see the time execution time for the job, the last execution time, the average, the maximum. So it turns red if it's higher than 50 seconds. It's just for last 24 hours. For SQL Server, we also show if the query store is in use, which have similar functionality to performance module, to dbwatch performance module. And we can see the query store in use. So we can see that it's used on one database. We also see some statistics about missing indexes. So you can see, okay, which instance has collected most data about missing indexes. So you can see it here. So you will get a view for all the instances on one platform. And of course, if you look at Oracle, then you will see similar data for Oracle, and then for Postgres also will be similar view like this. So we have discussed monitoring module, the SQL statistic job, which is very important to install. Otherwise, you won't gather any statistics. And the most important part is the management part, where you can analyze data. That's the interesting and most important part. But there is also a very important part is the repository overview, where where you have to manage your repository, and you have to be aware that we are not consuming too much resources, because it's impossible to analyze in a database instance without interacting with it, and trying, of course, interact as little as possible, but gather enough information so you can actually say something about the conditions on that instance. And the last thing, once again, to be able to use this module, you have to have a license. So let me show you to find it and how to enable it. So let's go back here. So we can do it from monitoring. So let's say if you have this SQL Server instance, you right click on it and then select configure instance. And here you have the license. So you need to have demo license, or you need the SQL performance package license. Then it will be possible for you to install SQL statistic job, which then will collect statistics, which you can analyze after some time. Okay, so back here, and that's actually all.
Thank you, Marek. That was insightful. We have some questions from the audience, and it's regarding doing this performance monitoring on like cloud-based systems versus the on-premise.
There's no problem with monitoring instance on off-premise. Let me take a look. I think we have one of the instances here. If I group them by default, there is one instance here on in the cloud, actually in AWS cloud. So if we support the cloud, then there's no problem. So if you have a managed instance, which is just a cloud version in Azure on SQL Server, for example, you can install the boot engine on it, install the job, and monitor it. So the answer is yes. Yeah, you can monitor off-premise.
Very good. I don't think there is any other questions on it. Go back to that. Yeah. So if you want to try out DBWatch, it's possible to scan the QR code here from the webinar slide, or you can go to our main page and register in our portal for a 3-month free trial license. Also, I encourage everybody to sign up for the next webinar, where we will focus on security and compliance on SQL Server, how we can use DBWatch to both to get compliant and also maintain the compliance once we reach that. If there is any other questions from this webinar, feel free to reach out, either sales@dbwatch or support@dbwatch.com. You can also go on our webpage at dbwatch.com and go for insights and request a demo if you have any want to see a full demonstration one-to-one. Other than that, I thank you all for attending this webinar, and I hope to see you again in a webinar in the future in a month's time. Thank you for your attention, and have a nice day. DBWatch Control Center, redefining database operations. Please visit us at Facebook, Twitter, LinkedIn, or YouTube.